Hi, welcome back. We're continuing to talk about inverse relations. And what we're going to talk about now is this question, are the inverses of all functions also functions? So to talk about this, we really need to start with what is a function? A function is a relation for which each input there is exactly one output. So this means every x value that goes into the function has exactly one output, or y, that comes out of the function. This means you couldn't have the ordered pair 2, 3, and 2, 4. So if we're looking at a situation like our last example that we looked at, we had this relation A, 1, 5, 3, negative 2, and 6, 1. This original relation A is a function. Each input, we have the inputs 1, 3, and 6, and they each have their own output. When I look at my inverse relation, this is also a function. And this is also a function because it has, for each of the inputs, 5, negative 2, and negative 1, there are 3 different inputs and there are 3 different outputs. So this is a function. It's the different inputs having an output. So there's no repeated input. I can pretty easily think of a function. So here is an example. If we have f of x is equal to this relation 1, 2, 3, 2, and 4, 2, this is a function. So this is my original relation. It is a function. I have the inputs 1, 3, and 2, and they each have an output. If I find f inverse, I do this by just reversing my ordered pairs, the x and the y components. So this gives me 2, 1, 2, 3, and 2, 4. This is now not a function. This is not a function because the input 2 has more than one output. So it is not always the case, but we can kind of generalize this. If a function is 1-to-1, then its inverse will also be a function. And a 1-to-1 function is a function which has, for each input, there is only one output, and for each output, there is only one input. If I'm looking for an example of a graph, graphically, something that will not have an inverse, that is also a function. If I look at the square root graph, if I were to reverse my x and y coordinates, I end up getting a graph that looks like this, which does not pass the vertical line test. And the vertical line test is one of the ways that we can talk about whether or not something is a function. So this is not this inverse. So this would be f, and this would be f inverse. And this is not a function. However, my original relation was a function. So inverse relations will not always be functions. However, we will sometimes need to change our domain or range of our inverse to make it a function depending on what we want to do.